Okay, this next example will certainly test our ability to factor. We will notice that it is a division problem, so once again, we will want to make this become multiplication and switch the numerator and denominator. So I'm going to do that within one step here. But in terms of the factoring component, the x squared minus 16 will factor into x plus 4, x minus 4. That is a difference of two squares. The 2y plus 36, we can take out a GCF of 2 and factor that into 2 times the quantity y plus 18. Again, we're going to switch this into a multiplication problem, which again incorporates the switching of the numerator and the denominator. So the y squared minus 3y minus 18 will factor into the y minus 6 and y plus 3. And finally, the x squared plus 12 or minus 12x plus 32 will factor into x minus 8 times x minus 4. Again, we are going to look vertically to see if we can cancel anything out. So if I look at this, there is nothing alike. If I look at this part, again, nothing alike. So we cannot factor anything out of either of those two items. So now I'm going to look diagonally. And the only item that cancels out are the x minus 4s. Remember, with the factors, there you can only cancel out identical items. So that's it. And we just rewrite our answer now as x plus 4, y minus 6, and y plus 3 in the numerator, and the y plus 18 and the x minus 8 in the denominator. Our next example looks really ugly, but we just have to keep in mind that all we're really saying is this divided by this. Okay? So if we rewrite that, it looks a little bit more friendly in this structure. So after we do that, we would then again make it become a multiplication problem. So I would do x minus 1 over x times 4x squared over x squared plus 1. And we would continue on with that. The solution for example 6, number 1, can be found via the notes in chapter 8 on my website. The last example I want to talk about is just a multiplication problem. So two rational expressions that are being multiplied together. We haven't looked at one of those. Unlike division, we don't have to do anything on the front end. So we do not have to take the reciprocal of the second part here. We can just move right into factoring. The x cubed plus 8, we do have to recall how to factor that. And I'm also going to look at this x squared minus 4. So the x squared minus 4 is just a difference of two squares, so that factors into x plus 2, x minus 2. The x cubed plus 8, remember that factors into a binomial times a trinomial, so we have a total of 5 spots to fill there. To obtain the two items in the binomial, we are going to take the cube root of both x cubed and 8. So the cube root of x cubed is x, and the cube root of positive 8 is plus 2. If this sign right here was minus, then it would be x minus 2. To fill the other three terms, we will base that off of what we have here in the x plus 2. So we will square both of those terms. So x squared is x squared, and 2 squared is 4. So those will be the first and the last terms in the trinomial. And then what we will do is multiply this term and this term together. So we'll multiply x times 2. That gives us 2x. And then we will take the opposite of that, and that will be our middle term. Okay? So that is how we factor a sum or difference of cubes. Nothing here factors in that second part. X minus 2, we can't do anything with that. And then for the x squared minus 2x plus 4, there are no two numbers that multiply to 4 and add a negative 2. So we can't do anything with that. Again, what I would do is look vertically to see if I can cancel anything out. So if I look at this part right here, I can cancel out the x plus 2's. So I'm going to go ahead and do that. I could also look over here, but there is nothing that can be canceled there. So now I look diagonally. These two trinomials are identical, so I can cancel those out. All right, remember, you can't cancel out pieces of binomials, trinomials, etc. But if they are identical, you certainly can. And we can do the same thing with the x minus 2. So with that canceling party, everybody's invited. And often people would say nothing's left over, but truthfully, if you take everything and you divide by itself, the answer is 1. That is all. Have a great weekend, everybody.